So now we're going to move on to the key topic. We're trying to find out how to construct quadratic equations from their solutions. Normally, you start from a given quadratic equation like this, for instance, and then you obtain the solutions by either using, so this is a quadratic equation, by either using the quadratic formula, the method of completing the square, or the method of inspection. And you get solutions. So you get usually two solutions. I mean, you always get two solutions. They're either the same or they're different. So the first solution I'm calling x1, the second solution I'm calling x2. We're trying to do the reverse process. We're trying to start from the solutions and arrive at a quadratic equation whose solutions are the ones we started with. So the general problems you face with regards to this topic are of the form where you'll be given the roots of a quadratic equation. So you'll be told that the roots of a quadratic equation are x equals x1 and x equals x2, where x1 and x2 are just some real number values. And you'll be asked to find a quadratic equation whose roots are the ones that were given. And all you have to do is use this equation here. So if I tell you, it's as simple as this, if I tell you that the roots of a quadratic equation are x equals 2 and x equals 3, all you have to do is say, well, okay, the first root given here is x1, which is 2, the second one is x2, which is 3. So the quadratic equation whose roots are 2 and 3 simply given by x minus x1, 2, times x minus x2, so x minus x2, which is 3. So note that x here is a variable, but x1 and x2 are real number values. So, well, in this case 2 and 3 equals 0. And this is the quadratic equation. So all I have to do now is just expand. So I'll just do that quickly. X times x minus 3 minus 2 to x minus 3. So I'm just expanding this to give x squared minus 3x minus 2x plus 6 equals 0. And that gives x squared minus 5x plus 6 equals 0. And what we've just done is obtain a quadratic equation whose roots are 2 and 3. And it's as simple as this. So you just need to remember this and you know how to construct quadratic equations from their roots. So this is a root or a solution to the quadratic equation, and that's another root. So x2, x1 is a root and x2 is a root. So you can try solving this equation using the quadratic formula or the method of completing square or any other method you like, and you'll find that the roots you get are the ones we started with. So you can always do that as a test to check that your answers are correct. Or in fact, all you just need to do is first realize that the roots of a quadratic equation are the solutions to that equation, which means that they must satisfy the equation. So when x is 2 and x equals 3, in this equation, this equation must be satisfied. So let's try that. I'm going to replace x with 2. So instead of x squared, I'm going to have 2 squared. And instead of minus 5x, I'm going to have minus 5 times 2 plus 6. That's the left-hand side of the equation when x is 2. When x is 2, and that gives 4 minus 10 plus 6. 4 minus 10 is minus 6. Minus 6 plus 6 is 0. What's the right-hand side? 0. So the left-hand side is equal to the right-hand side of the quadratic equation when x is 2. So we know that this equation we obtained is valid. It's correct because, or let's put it this way, a root of this equation, a solution of this equation is x equals 2. Let's test the other root when x is 3. So when x is 3, the right-hand side of the equation, as you can see, is just 0. But the left-hand side of the equation, x squared minus 5x plus 6, is 3 squared minus 5 times 3 plus 6, which is equal to 9 minus 15 plus 6. 9 minus 15 is minus 6. So plus 6 gives 0. Again, for this quadratic equation, when x is equal to 3, the equation is satisfied. So you know that 2 and 3 are solutions to this equation. Since we started with 2 and 3 and we obtained this equation, we know that this equation is the quadratic equation whose roots are the ones we started with.